presentation that kind of goes along with what his study guide does. So without further ado, why ham radio? Why is amateur radio called ham radio, first of all? Ham was actually the station call of the first amateur wireless station in 1908, operated by the Harvard Radio Club, Albert Hyman, Bob Almy, and Poogie Murray, or the Hyman Almy Murray or Ham station. So that's where ham radio got the name ham. Ham radio is fun. It's a fun hobby. You can talk to other ham radio operators locally and around the world, as depending on your license class. You can participate in amateur radio direction finding, which can be very entertaining. That's basically hunting down what they call fox hunting, chasing little transmitters that are hidden in the woods or where have you, trying to figure out where they're located using directional antennas. That's a lot of fun. Field days are designed to set up one or multiple ham stations in the field. So that's basically without any support from the power grid or anything like that. So that's in a basically a disaster scenario. You will be setting up your station independent of any resources, and that's a lot of fun to do too. It also tends to be kind of a picnic opportunity a lot of times for ham clubs to get together and do that. Satellite radio is interesting. There are multiple amateur radio satellites that are orbiting around the Earth. You can actually use those even as a technician, as an entry-level ham radio operator, to talk to those and use those satellites, and that can be a lot of fun. Packet radio is a digital mode, so you can actually send data through ham radio, through amateur radio, just like the internet. It's very similar to that. Typically less bandwidth, but can be very interesting technology to play with. For emergencies, search and rescue, obviously I participated in search and rescue with ham radio resources in the past for our local emergency management agency. Disaster communications and RACES, Radio Amateur Civil Emergency Service, is a division of typically your local civil emergency service, and that is designed to be activated in an emergency when normal communication means are down. Obviously, cell phones, your telephones, the internet, typically all of those are going to depend upon the grid and upon the existing infrastructure, and are very fragile and can go down due to any number of issues. And usually the only thing that works when that infrastructure goes down is ham radio. So with regard to ham radio, there are 3 license classes currently available from the FCC. The technician class license is the initial license that you get. It's used primarily for VHF and UHF local communication, which you'll learn more about here in a little bit, and what this course is primarily focused on. General is the second level, and that provides more high-frequency privileges. So those basically are the technologies used for speaking around the world. And the amateur extra is the highest class license, which is all privileges and frequencies available. Clubs are a lot of fun. There's the Amateur Radio Relay League, which is the national club, and there are also local clubs that are involved in amateur radio around the country, and they're a lot of fun to get involved with as well. If you Google the ARRL exam locations to find an exam site, you'll find the list. You can actually search their database to find a place where you can take your test. The cost is $15 to take that test. Modern handheld transceivers are as little as $50, so that's a big difference from when I first got my license, and the cost was upwards of $300-400 for your first handheld transceiver for a good one. And now you can get pretty decent ones for not a lot of money. So it's much improved in that respect. And now on to training, which will be the rest of the course. Basic electricity. So starting with basic electricity, voltage is the first thing you need to know, and that is the electrical term for the electromotive force, or a force that makes something happen. As we go through this course, you'll notice that certain items are in bold. Those items in bold are actually the test questions, so those are going to be things that you need to know that are on the test in order to get your technician license. The volt is the basic unit of electromotive force. About 12 volts is the amount of voltage that a mobile transceiver usually requires, or that's a radio that you'd have in your vehicle, for example. So if you get a 12-volt battery, most of those radios are going to require a voltage in that range. Current is the name for the flow of electrons in an electric circuit, so you can think of water moving through a hose. That would be current. The size of the hose would be the voltage. Electrical current is measured in amps or amperes, and direct current is the name for a current that flows only in one direction. So typically your car battery, you've got a positive and negative, and it flows from one to the other. Alternating current is the name for a current that reverses direction on a regular basis. So that's typically the power in your home. You can see on the graph there to your right, this is alternating current. So this would be no power right here on the 0, and this would be basically a positive and a negative alternating. 60 times per second, or 60 hertz, or 60 cycles per second would be the alternating current in your home. And frequency is what I was just using, which is cycles per second, the term that describes the number of times per second that an alternating current reverses direction. Resistance is the term used to describe the opposition to current flow in a circuit. The basic unit of resistance is the ohm, denoted by that symbol right there. Conductors are materials that conduct electrical current well, like copper, for example, and insulators are materials that have a high resistance, like glass or plastic, for example. The term that describes the rate at which electrical energy is used or generated is power. Electrical power is measured in watts. So here we have Ohm's Law. This is very important, and there are many test questions based on this. It's actually not nearly as complicated as it looks. Ohm's Law is the energy in volts equals the current in amps, represented by an I, times the resistance in ohms. Another way to remember that is to use the formula in your head, VCR, or volts equals current times resistance. That's another way to think about it. The power calculation formula, which is based on Ohm's Law as well, of a DC circuit, is P equals E times I, is the way that the FCC listed in the test question. I learned it as pi, P equals IE, when I went through electricity and electronics class. Power in watts, basically, equals the energy in volts times the current in amps. And again, current is represented by the I. Or another way to remember that is PVC, or power equals volts times current. So this is the easiest way that I've found to deal with Ohm's Law and to keep it straight in your head. If you draw a circle and then you put PIE, just like that, for Ohm's Law, EIR, that's going to make it very easy to do the calculations. So this is P equals IE is what this is, and E equals IR is what that is. But when it's drawn like this, all you really need to do is remember to block out the item that you don't have, and then you can calculate the item between with the other items that you do have to get what you don't know. For example, let's say you need to know the amps in this circuit. You don't know it, but you've got the watts and the volts. So I'm going to cover that up, and all you need to do, because this is over top of the other one, it's telling you to divide. So watts divided by volts is going to tell you how many amps are in that circuit. Very simple. If you don't know the watts, for example, cover that up. These are right next to each other, so that's multiplication. So your amps times your volts, and that's going to tell you your watts. Pretty straightforward. Likewise over here, same exact thing. Let's say you don't know the ohms of resistance in this circuit. You're going to cover that up, and then you're going to do your volts divided by your amps, and that's going to give you your ohms. If you don't know, your volts, for example, you can cover that up, and you're going to do amps times ohms, and that's going to tell you the volts. So that makes it relatively straightforward, at least for me, to keep it in my head when you're doing the math for it. And I'm going to do just a couple of examples here that are actually on the test. There are several of these, so it definitely behooves you to remember these, to learn them. And they're not not terribly complicated to learn. It's just the two formulas. But basically, one of the examples that they have on the test is 13.8 volts times 10 amps, and they want to know how many watts that is. So we would take, let's go ahead and write it in up here. So I'm going to do 13.8 volts is what we know, and we know it's 10 amps. So we're going to cover this up, and we're going to multiply 10 times 13.8, and what is that? That's 138 watts. Problem solved. And then likewise over here, we have another problem with resistance in the equation. So the book basically asks you, it gives you 90 volts and 3 amps are the two pieces of information that it gives you. So we're going to write in 90 volts here and 3 amps. So in this case we don't know this one, so we divide. So 90 divided by 3 is 30. So that tells us that the answer is 30 ohms. So relatively straightforward. The questions that they pose to you are in the form of a word problem. So they typically will tell you that you're dealing with a circuit with X number of volts and a resistance of X number of ohms, and you know, find the amps. You know, basically. So you'll have to obviously use your brain a little bit and convert that into this formula. But all you're looking for are the two pieces of information they give you, and obviously the one that they don't, and calculate that out in order to get the answer. I hope that was helpful. Electronics metrics, the metric system. So basically that's how you describe, we use the metric system to describe the levels of many electronics items such as volts or amps or ohms or hertz, etc. So giga is a billion, mega is a million, kilo is 1,000, milli is 1,000th, micro is a millionth, nano is a billionth, and pico is a trillionth. So these are the typical ones that we use, and those are the representations of the symbols that are used for those values. And some examples going down the line here. 1 gigahertz is 1,000 megahertz. 1 megahertz is 1,000 kilohertz. 1 kilohertz is 1,000 hertz. 1 millivolt is 1,000th of a volt. Micro, also note that it uses the Greek symbol mu to represent micro, so it's different than just the letter. When we get to nano here, 1 nanovolt is a billionth of a volt, and 1 pico ohm, for example, is a trillionth of an ohm. So just as in some examples as to how to use that. So always keep in mind when you're working with numbers and electronics, what these representations, what these mean when you say a gigahertz, so you understand that that's a billion hertz or 1,000 megahertz. Decibels are used to discuss and describe ratios like power ratios. Decibels are on a logarithmic scale, not a linear scale, so this will take some getting used to for you to think in a different manner. These are relative values that increase exponentially as they go up, and not just on a regular scale. So, for example, 6 is not twice of 3, and you know, 10 divided by 4 isn't necessarily 2.5 when you're talking about decibels. So, 3 decibels.
Hey, Randy Myrtle, welcome to the show, buddy. Good to have you.
Is the approximate
And good luck
amount
on your
of change
test
of
there.
a power increase from 5 watts to 10 watts. So you're doubling the power there from 5 watts to 10 watts, and that's actually a you know, a 2-to-1 ratio, or twice as powerful, and that's 3 decibels. So if you have a signal that's 3 decibels stronger than another signal, then it's going to be twice as powerful. Likewise, 6 decibels, and in this case the test question uses a negative number, which works the same way in either direction. So negative 6 decibels is the approximate amount of change of a power decrease from 12 watts to 3 watts, or a 4-to-1 ratio. So 4 times less powerful in this case, since it's a negative number. 10 decibels is the approximate amount of change, or a power increase, from 20 watts to 200 watts, or a 10-to-1 ratio. So 10 times as powerful. So in this case, 10 decibels is actually 10 times as powerful. 6 decibels again is 4 times as powerful, and 3 decibels is 2 times as powerful. So if you remember those 3, that will get you by pretty far for now. It'll certainly get you through the technician test. Radio waves. So radio waves are electromagnetic. That's the type of wave that they are. And electromagnetic, as it states here, is the type of wave that carries radio signals between transmitting and receiving stations. Radio waves are electromagnetic waves that travel through space. These radio waves consist of both electric and magnetic fields, hence the term electromagnetic. The hertz, or hertz, is the basic unit of frequency, named after Heinrich Hertz, and that represents 1 cycle per second on the alternating current scale, if you recall how that looks. The abbreviation RF refers to radio frequencies of all types. A radio wave travels at the speed of light through free space, which is about 300 million meters per second. So wavelength is the name for the distance a radio wave travels during one cycle, or one wave. Since radio waves also are always travel at the speed of light, but wavelengths get shorter as the frequency increases, we can actually use a formula. We can use math to convert a frequency to a wavelength. So the wavelength in meters actually equals 300 divided by the frequency in megahertz. Sometimes we refer to a band, like a ham radio band, by the wavelength. For example, the 2-meter ham radio band is actually between 144 and 148 megahertz. So if we do the math here to see where that falls, 300 divided by 148 is actually 2.03 meters, so just over 2 meters. So that's why we call the 2-meter band the 2-meter band, because the wavelength is 2 meters long, flying through the air, flying through space. The frequency spectrum covers basically all energy transference and includes sound waves, which are 20 hertz to 20,000 hertz, radio waves, which are above that, light waves, which are above that, and then more beyond that. So that's a good way to think about it. Energy transference is through that spectrum, and our voice, my voice that I'm using to speak with you right now, is simply a lower frequency than the radio waves that we use to communicate. It's the same technology, essentially. I mean, it works in a different manner electrically versus audibly, but it's the same spectrum. Remember that 1 kilohertz equals 1,000 hertz, 1 megahertz equals 1,000 kilohertz, and 1 gigahertz equals 1,000 megahertz. So the radio frequency spectrum is divided into several different regions, as we call them. VLF is very low frequency, so that's 30 hertz to 30,000 hertz, or 30 kilohertz. Low frequencies are considered between 30 kilohertz to 300 kilohertz. Medium frequencies are between 300 kilohertz to 3 megahertz. High frequencies, or HF, is between 3 megahertz to 30 megahertz. That's a test question. It's in bold there, so remember that. VHF, or very high frequencies, are between 30 megahertz to 300 megahertz. And then UHF, ultra high frequencies, are between 300 megahertz and 3 gigahertz. Also, just for information, super high frequencies are considered between 3 gigahertz to 30 gigahertz, and then EHF, or 30 gigahertz and above. I believe that's extra high frequencies, and typically aren't used unless you're using some dish-to-dish type of communication. But hams actually do have rights in some of those very high areas to do experiments and all kinds of things. So this is the band plan, the U.S. amateur radio bands. This is a very, very useful chart. I highly recommend that you find it, you print it. It's on the ARRL website, a document that they created. But it helps you to visualize the ham bands that we typically use. And again, this isn't comprehensive. It's not all of them, but it's a big part of them. As a technician, you are able to use basically everything above 50 megahertz, and then today you've got rights on some HF frequencies as well that I didn't have when I got my license back in 1996. So let's just we'll start from the top down just to make it a little easier. 23 centimeters. You can see these red and green lines here represent what you can do with those frequencies. And they also represent you can see out to the side here, EAGT, that stands for the license class. Now let me mention here too, we're talking about some license classes that are no longer really applicable. You can't get them anymore. Over on the right here, you'll see that you've got E for amateur extra, A for advanced, G for general, T for technician, and N for novice. Well, today you can really only get the technician license, and then you can upgrade to general and then extra. The advanced and the novice no longer apply. There are still some people who have those licenses and that are left over from when they got them before they changed the licensing scheme, and that's why those are listed on this chart, so you can see what you have rights to if you have one of those licenses. So red is RTTY, which is radio teletype and data transmissions. Green is phone and image. Yellow is sideband phone only. And then there are some other options as well here, like for example CW only or Morse code only. So way up in the 1.2 gigahertz range, or 1240 megahertz range here, is the 23 centimeter band. Certain uses for it, obviously not real popular. You're probably not going to run into that a lot unless you get a radio that's capable of it and use it for a specific thing. Same thing for 33 centimeters. But as we move down here into the 70 centimeter band, 420 megahertz is where it begins, 420 to 450. 440 is what it's typically known as. So when you hear 70 centimeters or someone say the 440 band, that's what they're referring to. And this is UHF between 420 megahertz to 450 megahertz, as I mentioned, and you have rights as a technician through all of that to use for phone or data, any of those frequencies. 1.25 meter band or 222 megahertz band is kind of in between the two most popular VHF and UHF bands, but you do have several rights in there to do all kinds of cool things too. The two most popular bands, when you typically go out and buy a handheld transceiver, usually it's going to be a dual band radio that's going to be capable of operating 2 meters and 440, as we call it. And so that's going to give you rights on this 2 meter band. I mean, you're going to be able to use your radio on that, as well as this 70 centimeter band or 440 band. And that's where a lot of the activity is, local activity. Most of the activity locally is going to be on 2 meters or 440 typically. You do see in here there is a section reserved for Morse code at the bottom of 2 meters. So if you're interested in learning Morse code, you can use your skills there to practice. Pretty neat stuff. 6 meters, 50 megahertz, you've got full rights to that as well. That propagates slightly better depending on what you're using it for. This is usually the highest that you're going to get what they call skip, or basically being able to bounce signals off the ionosphere, and it's very limited at that high frequency. It just at certain times of the year, and when there's sunspot activity in certain geomagnetic events, you may be able to use skip on that band. And then as you go down, that becomes more prevalent, being able to talk around the world when you get into the HF frequencies that we're kind of down to now when we're looking at these over here on the left, or in the middle, I guess. So 10 meters is the next one, 28 megahertz. That's just above the Citizens Band radio at 27 megahertz. One cool thing as a technician now, this little yellow area, you actually do have SSB phone rights to be able to use voice down that low in an HF band. Now again, 10 meters is a little high for regular, what they call DX propagation, or propagation around the world. It does happen. It does happen from time to time. And you can learn to watch the bands, and there are sites on the internet that track the activity of the ionosphere. And at certain times, you can hear people from all over the place. As we go down here, we've got 12 meters at 24 megahertz. And, that actually is, there's nothing here that you can use as a technician, but it is available for amateur extras, advanced, and general license holders. And then as we go down in 15 meters at 21 megahertz, there is a technician slot here. It's Morse code only at that point. From here on down, there's just a few areas where you do have rights to use those frequencies for Morse code only. But it's a good place to talk around the world as a technician. If you learn Morse code, or even if you have you can use a computer to translate Morse code for you, and that gives you that ability to actually have long-distance communication just as a technician, which is very nice. As we go down below 15 meters, we've got 17 meters at 18 megahertz, 20 meters at 14 megahertz. I'll mention that 20 is the most popular for propagation. It usually propagates pretty much 24/7 around the world. So a lot of DX communications are happening on 20 meters. 40 meters is also a popular band at 7 megahertz. I'm sorry, I skipped 30 meters here. 30 meters is kind of one of those special bands with certain, there's a lower power limit, 200 watts peak effective peak envelope power on 30 meters. And it's just RTTY and data. But 40 meters is 7 megahertz. That's a pretty popular band. And again, you do have rights down here as a technician with Morse code. And 40 meters and below pretty much are active primarily at night, except for local communication. Due to the way the ionosphere works, they will propagate around the world at night. 40 meters will, 80 meters will, 160 meters will, but you do have rights in the 80 and the 40 at night, and also the 60 meter band, which is strange for an amateur radio band because it's actually channelized. You've got certain channels that we can use as secondary users on that band. But this is the amateur radio band plan in a nutshell that's currently active. So it's very good to read this, study it, understand. You know, if you can wrap your head around these bands and what's what, especially the technician bands, you'll have a real good understanding of the frequencies that we can operate on. And as you learn more about the frequencies and propagation, you can learn about the cool things that you can do on each band. Radio wave characteristics. Communication at VHF and UHF frequencies is generally line of sight. So that's that 2 meter and 440 that I was talking about, meaning that they travel straight from the transmitter to the receiver and cannot penetrate the earth and usually are not reflected by the ionosphere. The radio horizon is the distance at which radio signals between 2 points are effectively blocked by the curvature of the earth. That said, the earth seems less curved to radio waves than light, and again, that's a test question. So UHF and VHF waves actually do tend to travel about 15% farther than true line of sight. Multipath distortion can occur when the receiver receives radio signals via 2 or more paths. So that happens when your signal is reflecting off of objects. If this happens, try moving a few feet, as random reflections may be causing multipath distortion. That's what that's called. With data transmissions, error rates are likely to increase if VHF or UHF data signals propagate over multiple paths. A repeater is a transmitter and receiver usually located in an elevated position that extends the reach of your radio by repeating your signal. When using a repeater, you can use multipath to your advantage if you don't have line of sight to that repeater. Using a directional antenna, you can actually try to find a path that reflects signals to the repeater. So you can take a directional antenna and bounce your signal off of a mountain or a building and talk somewhere where you may not have direct line of sight to. UHF radios are typically better indoors because the shorter wavelength does allow them to more easily penetrate the structure of buildings. Knife edge propagation is another thing to be aware of, and that occurs when signals are partially refracted around solid objects with sharp edges like buildings. So if you've got a square building, your radio wave actually is going to refract around that a little bit. It's going to bend around it. Radio waves are mysterious things. They do some cool have some cool features. Also important at UHF and VHF frequencies is the orientation of the electric field, or antenna polarization. So that's when the antenna is horizontal or vertical. Signals can be significantly weaker if the transmitter and receiver do not use the same polarization. So repeaters typically use vertical polarization. Horizontal polarization is normally used for long distance or weak signal communications, weak signal Morse code, for example, CW, and SSB or sideband voice contacts. So it's important that you use the same polarization as the station that you're trying to talk to. Picket fencing is the term commonly used to describe the rapid fluttering sound sometimes heard from the mobile stations that are moving while transmitting. Sometimes when VHF signals are being received from long distances, what might be happening is the signals are being refracted from the sporadic E layer in the ionosphere. Sporadic E propagation is most commonly associated with strong over-the-horizon signals on the 10, 6, and 2 meter bands. On other occasional phenomena at VHF frequencies include auroral reflection, meteor scatter, tropospheric scatter, and tropospheric ducting. When receiving VHF signals via auroral reflection, the signals exhibit rapid fluctuations in strength and often sound distorted. 6 meters is the band best suited to communicating via meteor scatter. Tropospheric scatter is the mode responsible for allowing over-the-horizon VHF and UHF communication to ranges of approximately 300 miles. Temperature inversions in the atmosphere cause tropospheric ducting that propagate VHF signals for many hundreds of miles. This is where we're talking about the ionosphere a little bit and what it can do. So the ionosphere is part of the atmosphere that enables the propagation of radio signals around the world. During the peak of the sunspot cycle, or every 11 years, 6 or 10 meters may provide long-distance communications, as the lower HF frequencies regularly do. The best time for long-distance 10-meter band propagation via the F layer is from dawn to shortly after sunset during periods of high sunspot activity. The cause of irregular fading of signals from distant stations during times of generally good reception is random combining of signals arriving via different path lengths. Because long-distance communication that skips off the ionosphere often changes polarization, either vertically or horizontally polarized antennas may be used for transmission or reception when using skip. I'm going to talk briefly about radio services here. Without a ham radio license or otherwise commercially licensed, you're limited to a handful of relatively low power radio communication in the United States, which includes the 49 megahertz spectrum, which is very low power, short range walkie-talkies or cordless telephones that I haven't actually seen for several years, but you'll see a picture of here on the right. These little Archer radios are an example. I used to play with radios like that when I was a kid. 900 megahertz, also some relatively low power, short range cordless phones and things like that. The FRS, or the Family Radio Service, is in the 460 megahertz UHF territory, but it's limited to about half a watt power and relatively short range, maybe half a mile to a mile, depending on your terrain. A lot of times you'll buy the boxes in the big box stores, and they'll say up to 20 some odd miles. Well, that's only typically if you're like in the desert on top of a mountain talking to someone else in the desert on top of a mountain. If you have any humidity in the air, or if you're not in a vacuum, you're typically not going to see anything close to that range. It's very dependent upon your surroundings. GMRS requires an FCC license, but it does give you more power and range than regular FRS. It does use similar and actually even shares frequencies with the FRS. So GMRS and FRS are similar frequencies, and they actually overlap with, I believe, 7 other frequencies. Can communicate potentially several miles line of sight. As I mentioned, you do need an FCC license. I believe that's $80 or $90 now for, I think, 10 years. So keep that in mind. There's no test involved for that license, but something still you'd have to keep in mind. And then MERS is the multiple use radio system, which uses 150 megahertz VHF, also up to several miles. Another thing I didn't mention in other services, the Citizens Band Radio, CB radio at 27 megahertz. That's going to have a bit more propagation depending on what you're doing. Obviously, the radios are a little bigger antennas because they're the 11 meter band. But if you want any more capabilities than that, or if you want any kind of distance communication or to be able to use repeaters or range, there are some exceptions to that. But typically, you need to get your ham radio license to have any more capability than that. And that's kind of what we're doing right now. But I wanted to talk briefly about those services so that you're aware of the other radio services that are out there and what they can and cannot do. Electronics concepts. A resistor is the electrical component used to oppose the flow of current in a DC circuit. Most resistors have a fixed value in ohms, which is the resistance. Here's several resistors over on the right. A variable resistor is called a potentiometer, and that's often used to adjust volume or other such things where you have a rotary knob. There's a couple potentiometers. A capacitor is an electrical component with an insulator separated by 2 or more conductive surfaces. Its job is to store energy in an electric field. Capacitance is the ability to store this energy, and it's measured by the farad. An inductor stores energy in a magnetic field and is usually composed of a coil of wire. The ability to store energy in a magnetic field is inductance, and it's measured by a unit called Henry. A switch is an electrical component used to conduct or connect or disconnect electrical circuits. A fuse is an electrical component used to protect other circuits components from overloads. A battery is a device that stores electrical energy chemically. Some batteries, like carbon-zinc battery, are not rechargeable. Some rechargeable battery technologies are nickel metal hydride, lithium ion, and lead acid gel cell. A diode is an electronic component that allows current to flow in only one direction. Diodes have 2 electrodes, an anode and a cathode. A semiconductor diode's cathode lead is usually identified with a stripe, as you can see in the picture on the right. Light-emitting diodes, or LEDs, are a type of diode that emits light when current flows through them. A transistor is an electrical component capable of using a voltage or current signal to control current flow, such as amplifying a signal. The transistor can be used as either an electronic switch or an amplifier. Gain is the term that describes a transistor's ability to amplify a signal. A transistor is made of 3 layers of semiconductor material. There are 2 types of bipolar junction transistors. PNP is one type, and it has two p layers and one n layer, giving it a net positive charge. So that's easy to remember because there are two positive layers and one negative layer, which gives it more positive than negative, giving it a net positive charge. An NPN has two n layers and one p layer, giving it a net negative charge. Both types consist of three electrodes, an emitter, a base, and a collector. A field effect transistor, or FET, also has three electrodes, a source, a gate, and a drain. Understanding schematics. Schematic symbols are standardized representations of components in an electrical wiring diagram. These symbols represent electrical components. The way components are interconnected is accurately represented in electrical circuit schematic diagrams. Figure T1 is a schematic diagram of a lamp that turns on when a positive charge is applied to the input. Now, this is one of the schematics that's actually on the test, so there are several that questions will be drawn from, so it's good to learn these schematics and the components on them. Component 1 is a resistor that limits the input current. Component 2 is a transistor that controls the flow of current to the lamp, or turns it on and off. Component 3 is the lamp itself. Component 4 is the battery. In figure T2, a simple power supply component 3 is a single pole, single throw switch that turns the power supply on and off. Component 4 is a transformer, which is commonly used to change 120 volt AC house current to a lower AC voltage for other uses. A rectifier diode, such as component 5, changes AC into varying DC signals. Component 6 is a capacitor. In this case, its job is to filter the 60 Hz component of the rectified AC. Component 8 is an LED to light up when the power supply is on. Component 9 is a potentiometer whose purpose is to limit the output current. In figure T3, the output circuit of a transmitter, component 3 in figure T3 is a variable inductor which is used in conjunction with a capacitor to make a tuned circuit. Component 4 is an antenna. An inductor and a capacitor connected in series or parallel to form a filter is a simple resonant or tuned circuit. A relay is a switch controlled by an electromagnet. A meter can be used to display signal strength on a numeric scale. An integrated circuit is a device that combines semiconductors and other components into one package. ICs may perform analog or digital functions. One type of analog integrated circuit is a voltage regulator. A regulator is the type of circuit that controls the amount of voltage from a power supply. When connecting circuits together, sometimes we use conductors with a shield around them that is connected to ground. This is typically to prevent coupling of unwanted signals to or from the wire. Antennas and feed lines. A horizontally polarized antenna is one that is parallel to the Earth, while a vertical antenna is one that is perpendicular to the Earth. A half-wave dipole antenna is a simple antenna that measures roughly a half a wavelength end to end. The direction that radiation is strongest from a half-wave dipole antenna in free space is broadside to the antenna. Due to stray capacitance from objects near the antenna, including the ground, a typical dipole is actually about 5% shorter than half a wavelength. For example, the approximate length of a 6-meter half-wave dipole is 112 inches. To make a dipole resonant on a higher frequency, you would shorten it. While a dipole is usually horizontally polarized, a popular vertically polarized antenna is the quarter-wave vertical. The approximate wavelength of a vertical antenna for 146 MHz is 19 inches. Antennas can be shortened by using a loading coil, which is to insert an inductor in the radiating portion of the antenna to make it electrically longer. A directional antenna is an antenna that concentrates signals in one direction. Directional antennas include beam, quad, Yagi, and dish antennas. And over on the right, bottom right, is an example of a Yagi antenna. The gain of an antenna is the increase in signal strength in a specified direction when compared to a reference antenna. Most handheld radios use a rubber duck antenna, which does not transmit or receive as effectively as a full-sized antenna. Also, when using such an antenna in a vehicle, signals can be significantly weaker than when outside of the vehicle. Mobile VHF and UHF antennas are usually mounted in the center of the vehicle roof because a roof-mounted antenna normally provides the most uniform radiation pattern. A 5/8 wave VHF or UHF antenna typically offers a lower angle of radiation and more gain than a quarter wavelength antenna and usually provides improved coverage. Feed lines connect your radio to your antenna. Most often, coaxial cable, or coax cable, is used for this task because it's easy to use and requires few special installation considerations. A common use of coax cable, then, is carrying RF signals between a radio and antenna. Loss increases as the frequency of the signal passing through coaxial cable is increased. When you choose a feed line, it's important to use one with the same impedance as the antenna. Impedance is a measure of the opposition of current to AC current flow in a circuit. Ohms are the units of impedance. Most amateur radio transmitters have an output impedance of 50 ohms. Therefore, the most commonly used coax cable in amateur radio installations is 50 ohms, like RG58 and RG8. The larger RG8 cable has less loss at a given frequency than RG58. Air-insulated hardline has the lowest loss at VHF and UHF frequencies. Moisture contamination is the most common cause for failure of coax cables. Ultraviolet light can also damage the jacket and allow water to enter the cable. A disadvantage of air core coax cable when compared to foam or solid dielectric types is that it requires special techniques to prevent water absorption. PL259 coax cable connectors are commonly used at HF frequencies. Type N connectors are more suitable for frequencies above 400 MHz. There's an example on the right of a PL259 on top and a Type N on the bottom. All cables should be sealed against water intrusion to prevent an increase in feed line loss. A loose connection in an antenna or feed line might cause erratic changes in SWR readings to make sure all connections are tight. SWR, or standing wave ratio, is a measure of how well a load, in this case an antenna, is matched to a transmission line. In other words, they are matched if they have the same impedance. The reason it's important to have a low SWR is to allow the efficient transfer of power and reduce losses. Power lost in a feed line is converted into heat. You can measure the SWR with an SWR meter, which should be connected in series with the feed line between the transmitter and the antenna, usually as close to the transmitter as practical. A directional wattmeter can also measure SWR by measuring both the forward and reflected power, then calculate the SWR. An SWR of 1 to 1 indicates a perfect impedance match. An SWR of 2 to 1 is the value above which the protection circuits in most transmitters begin to reduce power. 4 to 1 indicates an impedance mismatch. An antenna tuner, which can be seen on the bottom left, can be used to match the antenna system impedance to the transceiver's output impedance. A dummy load consists of a non-inductive resistor and heatsink and is used to prevent the radiation of signals when making tests. So you can transmit into a dummy load if you don't want to transmit into an actual antenna and then therefore radiate a signal. An antenna analyzer, on the bottom right, is an instrument that is used to determine if an antenna is resonant at the desired operating frequency. Modulation and signals. Frequency modulation, or FM, is the type of modulation most commonly used for VHF and UHF voice repeaters, as well as for VHF packet radio transmissions. FM varies the instantaneous frequency of the wave to transmit information, like voice or data. FM is not used in HF frequencies due to the high bandwidth requirements. In the bottom right animation, you can see FM operating. You can see the signal as the signal changes. The signal is what you're trying to transmit, so be that voice or data, for example. As that information varies, using FM, the frequency actually changes. You can see it adjusting as that signal changes in order to transmit information. Amplitude modulation, or AM, varies the amplitude or strength of the signal to transmit information. AM is the oldest modulation method of radio transmission, and you can see down here with AM, as the signal changes, the amplitude of the AM changes as well to convey that information. Single sideband is a form of AM, but with the carrier and one extraneous sideband removed. SSB can be used as upper sideband USB or lower sideband LSB. SSB is the type of voice modulation most often used for long distance or weak signal contacts on VHF and UHF as well as HF bands. On the right, you can see some images that help to explain what sideband is, what single sideband is. So at the top you have a full AM modulation, which has the lower sideband and the upper sideband and the carrier all being transmitted, and that's typical AM. With SSB, you've eliminated, in the case of the middle image there, you have upper sideband. So you've eliminated the lower sideband and the carrier, saving a lot of power that can be used just for the transmission of the information now. So using SSB, you can typically transmit a lot more power based on the information than you can with AM or FM. And at the bottom you see LSB, or lower sideband. The primary advantage of single sideband over FM for voice transmissions is that the SSB signals have narrower bandwidth, typically 3 kHz, compared to a VHF repeater FM phone signal, which is between 10 and 15 kHz. Morse code, also known as continuous wave or CW, is the type of emission with the narrowest bandwidth, which is only about 150 Hz. International Morse is the code used when sending CW in the amateur bands. When transmitting CW, you can use a straight key, electronic keyer, or a computer keyboard. Some modes, such as analog fast-scan TV transmissions on the 70 cm band, have very wide bandwidths, about 6 MHz. The type of transmission indicated by the term NTSC is an analog fast-scan color TV signal. Digital modes can be used to send digital data rather than voice or analog signals. Often computers are used in conjunction with a transmitter to send digital modes such as packet, PSK31, or MFSK. A radio packet contains a checksum, which permits error detection, a header, which contains the call sign of the station to which the information is being sent, and an automatic repeat request in case of error. Automatic Packet Reporting System, or APRS, is a service that uses packet radio and a GPS, or Global Positioning System receiver, to send automatic location reports via amateur radio, providing real-time tactical digital communications in conjunction with a map showing the locations of stations is an application of APRS. Phase shift keying, or PSK, is a low-rate data transmission mode. PSK31 transmits and receives at 31 baud, and its bandwidth is about 31 Hz. Electrical safety. Always put safety first. Lethal voltage can be as low as 30 volts, and lethal current as low as 100 milliamps. That's not much. Current flowing through the body can cause a health hazard by heating tissue, disrupting the electrical functions of cells, and causing involuntary muscle contractions. Safety ground is connected to the green wire in all 3-wire electrical AC plugs and should be used for amateur equipment. When choosing a good way to guard against electrical shock at your station, use 3-wire cords and plugs for all AC powered equipment. Connect all AC powered station equipment to a common safety ground, and use a circuit protected by a ground fault interrupter. A fuse is designed to interrupt power in case of overload. When replacing a fuse, always replace the blown fuse with a fuse of the same type and value. For example, it's unwise to install a 20 amp fuse in place of a 5 amp fuse because excessive current could cause a fire, typically because the wiring and the circuit is simply not rated for that kind of current. A fuse or circuit breaker in series with the AC hot conductor should always be included in home-built equipment that is powered from 120 volt AC circuits. When working in equipment, always disconnect the power. Even then, you still might receive an electric shock from a stored charge in a large capacitor, so be very careful. With regard to a battery, shorting the terminals can cause burns, fire, or an explosion. Explosive gas can collect if not properly vented. And if a lead-acid storage battery is charged or discharged too quickly, the battery could overheat and give off flammable gas or explode. When putting up an antenna tower, always look for and stay clear of any overhead electrical wires. Make sure that any antenna is far enough from power lines that if the antenna falls unexpectedly, no part of it can come closer than 10 feet to the power lines. Also, don't attach any antenna to a utility pole, as the antenna could contact high voltage power wires. Position the antenna so that no one can touch it while you're transmitting. If a person accidentally touched your antenna while you were transmitting, they might receive a painful RF burn. When installing a tower, use a gin pole, which is designed to lift the tower sections or antennas. At all times, when any work is being done on the tower, members of a tower work team should wear a hard hat and safety glasses. Before climbing an antenna tower, it's a good precaution to put on a climbing harness and safety glasses. Never climb a tower without a helper or an observer. When using a crank-up tower, remember that this type of tower must never be climbed unless it's in the fully retracted position. Grounding is important because a tower is essentially a lightning rod. and local electrical codes establish grounding requirements for an amateur radio tower or antenna. Separate 8-foot long ground rods for each tower leg bonded to the tower and to each other is considered a proper grounding method for a tower. Always ensure that connections are short and direct, and avoid sharp bends when installing grounding conductors for lightning protection. When installing devices for lightning protection in a coax cable feed line, to shunt this current to ground before it gets to your shack, ground all of the protectors to a common plate, which is in turn connected to an external ground. VHF and UHF radio signals are non-ionizing radiation, which differs from ionizing radiation in that RF radiation does not have sufficient energy to cause genetic damage. Even so, it can be unsafe, and the maximum power level that an amateur radio station may use at VHF frequencies before an RF exposure evaluation is required is 50 watts peak envelope power at the antenna. To perform an RF evaluation to determine if your station complies with FCC regulations, you can do so by calculation based on FCC OET Bulletin 65, or by calculation based on computer modeling, or by measurement of field strength using calibrated equipment. Duty cycle is the percentage of time that a transmitter is transmitting and is one of the factors used to determine safe RF radiation exposure levels because it affects the average exposure of people to radiation. If the averaging time for exposure is 6 minutes, 2 times as much power density is permitted if the signal is present for 3 minutes and absent for 3 minutes, rather than being present for the entire 6 minutes. Exposure limits vary with frequency because the human body absorbs more RF energy at some frequencies than at others. The 50 MHz band has the lowest maximum permissible exposure limit. All of these factors affect RF exposure: frequency and power level of the RF field, distance from the antenna to a person, and the radiation pattern of the antenna. One action amateur operators might take to prevent exposure to RF radiation in excess of FCC-supplied limits is to relocate antennas. After the initial RF exposure evaluation, you make sure your station stays in compliance with RF safety regulations by reevaluating the station whenever an item of equipment is changed. A regulated power supply is often needed as it prevents voltage fluctuations from reaching sensitive circuits. Some microphone connectors include push-to-talk and voltages for powering the microphone. A computer can be used at an amateur station for logging contacts and contact information, for sending and or receiving CW, for generating and decoding digital signals. For packet radio, you will also need a terminal node controller, which converts from binary to tones sent over the air. When conducting certain digital communications like RTTY or PSK31 using a computer, the sound card provides audio to the microphone input and converts received audio to digital form. To reduce RF current flowing on the shield of an audio or power cable, you would use a ferrite choke. To reduce harmonic emissions, if it's an issue for your radio, a filter must be installed between the transmitter and the antenna. A flat strap is the type of conductor that is best to use for RF grounding in your station. A mobile transceiver's power negative connection should be made at the battery or engine block ground strap. One thing that could be happening if another operator reports a variable high-pitched whine on the audio from your mobile transmitter is that noise on the vehicle's electrical system is being transmitted along with your speech audio. The alternator is the source of a high-pitched whine that varies with engine speed in a mobile transceiver's receive audio. Filters can be used to mitigate this. One thing that would reduce ignition interference to a receiver is to turn on the noise blinker. If a transmitter is operated with the microphone gain set too high, the output signal might become distorted. The keypad or VFO knob can be used to enter the operating frequency on a modern transceiver. A way to enable quick access to a favorite frequency on your transceiver is to store the frequency in a memory channel. The purpose of the squelch control on a transceiver is to mute receiver output noise when no signal is being received. Don't set squelch too high or you'll block all signals. The common meaning of the term repeater offset is the difference between the repeater's transmit and receive frequencies. A transceiver is a unit combining the functions of a transmitter and a receiver. A multi-mode VHF transceiver is a type of device that is most useful for VHF weak signal communication. A device that would take the output of a low-powered 28 MHz SSB exciter and produce a 222 MHz output signal is called a transverter, allowing the use of an HF transceiver as a VHF transceiver. To increase the low power output of a handheld transceiver, and therefore its range, you can use an RF power amplifier. The two most important specifications for a receiver are sensitivity and selectivity. Sensitivity is the term that describes the ability of a receiver to detect the presence of a signal. The term that describes the ability of a receiver to discriminate between multiple signals is selectivity. To improve the sensitivity of a receiver, you can use an RF preamplifier. An RF preamplifier is installed between the antenna and the receiver. A mixer is used to convert a radio signal from one frequency to another. An oscillator is the name of a circuit that generates a signal of a desired frequency. Modulation is the term that describes combining speech with an RF carrier signal. A few causes of radio frequency interference are fundamental overload, harmonics, or spurious emissions. If someone tells you that your station transmissions are interfering with their radio or TV reception, you should first make sure that your station is functioning properly and that it doesn't cause interference to your own radio or television when it is tuned to the same channel or frequency. The first step to resolve cable TV interference from your ham radio transmission is to be sure all TV coaxial connectors are installed properly and tightened all the way. When a receiver is unable to reject strong signals outside the AM or FM band, it can cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally. One way to reduce or eliminate the overloading of a non-amateur radio or TV by an amateur signal is to block the amateur signal with a filter at the antenna input of the affected receiver. One way to reduce or eliminate interference by an amateur transmitter to a nearby telephone is to install an RF filter at the telephone. Who uses telephones anyway? Consider some or all of these devices to mitigate an interference problem. A snap-on ferrite choke, a low-pass and high-pass filter, or band reject and band pass filters. Your neighbors may have wireless devices, sometimes called Part 15 devices, that can interfere with your station. A Part 15 device is an unlicensed device that may emit low-powered radio signals on frequencies used by a licensed service. If something in your neighbor's house is interfering with your station, work with your neighbor to identify the offending device. Politely inform your neighbor about the rules that require him to stop using the device if it causes interference. Check your station and make sure that it meets the standards of good amateur practice. If you receive a report of poor audio from your radio, it may be that your transmitter may be slightly off frequency, your batteries may be running low, or you could be in a bad location. For testing, voltage and resistance are two measurements commonly made using a multimeter. You use a voltmeter to measure electric potential or electromotive force. The correct way to connect a voltmeter to a circuit is in parallel with the circuit. When measuring high voltages with a voltmeter, one precaution you should take is to ensure that the voltmeter and leads are rated for use at the voltages to be measured. An ohmmeter is the instrument used to measure resistance. When measuring circuit resistance with an ohmmeter, ensure that the circuit is not powered. Attempting to measure voltage when using the resistance setting might damage a multimeter. What is probably happening when an ohmmeter connected across a circuit initially indicates a low resistance and then shows increasing resistance with the time is that the circuit contains a large capacitor. An ammeter is the instrument used to measure electric current and is usually connected to a circuit in series with the circuit. Learning how to solder is also an important skill for amateur radio operators. Rosin core solder is best for radio and electronic use. A grainy or dull surface is the characteristic appearance of a cold solder joint, or poor solder joint. Operating. As previously discussed, a repeater station is the type of amateur station that simultaneously retransmits the signal of another amateur station on a different channel or channels. Auxiliary, repeater, or space stations can automatically retransmit the signals of other amateur stations. Repeaters receive on one frequency and transmit on another. You program your radio so that it receives on the repeater's transmit frequency and transmits on the repeater's receive frequency. The difference between the transmit frequency and the receive frequency is called the repeater frequency offset. Plus or minus 600 kHz is the most common repeater frequency offset in the 2-meter band, while plus or minus 5 MHz is a common repeater frequency offset in the 70 cm or 440 band. Duplex operation is used to describe operating using repeaters because you're transmitting and receiving on two different frequencies. When the stations can communicate directly without using a repeater, you should consider communicating via simplex rather than a repeater. Simplex communication is the term used to describe an amateur station that is transmitting and receiving on the same frequency. To help amateurs operating simplex find one another, frequencies on each band have been set aside as national calling frequencies. 446 MHz is the national calling frequency for FM simplex operations in the 70 centimeter or 440 band, and 146.52 MHz is the national calling frequency for FM simplex operation in the 2 meter band. Because repeaters often operate in environments where there is a lot of interference, they are programmed not to operate unless the station they are receiving is also transmitting a subaudible tone on a specific frequency. These tones are sometimes called PL, or private line tones, or CTCSS tones, short for Continuous Tone-Coded Squelch System tones. CTCSS is the term used to describe the use of a subaudible tone transmitted with normal voice audio to open the squelch of a receiver. If your radio has not been programmed to transmit the proper subaudible tone, when you transmit, the repeater will not repeat your transmission. If you can hear, but not access a repeater, even when transmitting with the proper offset, it could be that the repeater receiver requires an audio tone burst for access, or it requires a CTCSS tone for access, or the repeater receiver may require a DCS tone sequence for access. Carrier squelch is the term that describes the muting of receiver audio controlled solely by the presence or absence of an RF signal. Microphone gain is important because the amplitude of the modulating signal determines the amount of deviation of an FM signal. When the deviation of an FM transmitter is increased, its signal occupies more bandwidth. One thing that could cause your FM signal to interfere with stations on nearby frequencies is that you have set your microphone gain too high, causing overdeviation. When using a repeater, say your call sign to indicate that you are listening. For example, KB90KB listening. To call someone on a repeater, say the station's call sign followed by your own call sign. For example, KB90KB, KB90PV, KB90KB. That would be if I was calling KB90PV. Or I could say KB90PV, this is KB90KB. On the HF bands, when you want to contact another station, you call CQ. That is to say, you would say something like CQ, 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 this is KB90KB. The meaning of the procedural signal CQ is calling any station. When choosing a frequency to call CQ, listen first to be sure that no one else is using the frequency. Ask if the frequency is in use. Make sure you are in your assigned band. When responding to a call of CQ, you should transmit the other station's call sign followed by your call sign. An amateur operator must properly identify the transmitting station when making on-air transmissions to test equipment or antennas as well. When making a test transmission, a station identification is required at least every 10 minutes during the test and at the end of the test. As a technician, you will be able to operate Morse code on certain portions of the 80 meter, 40 meter, 15 meter, and 10 meter bands. To shorten the number of characters sent during a CW contact, amateurs often use three-letter combinations called Q signals. QRM is the Q signal used to indicate that you're receiving interference from other stations. The Q signal used to indicate that you're changing frequency is QSY. While consulting a band plan before operating is a good idea, realize that a band plan is a voluntary guideline for using different modes or activities within an amateur band. Regarding power levels used in the amateur bands under normal, non-distress circumstances, the FCC rules state that while not exceeding the maximum power level permitted on a given band, use the minimum power necessary to carry out the desired communication. When two stations operating on the same frequency interfere with each other, common courtesy should prevail, but no one has an absolute right to an amateur frequency. When identifying your station, when using phone, use of a phonetic alphabet is encouraged by the FCC, such as the NATO phonetic alphabet on the right. You can familiarize with those for A through Z. Going down the list, Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, Golf, Hotel, India, Juliet, Kilo, Lima, Mike, November, Oscar, Papa, Quebec, Romeo, Sierra, Tango, Uniform, Victor, Whiskey, X-Ray, Yankee, and Zulu. That makes it a lot easier when you're saying your call sign for somebody to understand it. For example, when calling CQ, I'll often say CQ, 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 Kilo Bravo 9, Oscar Kilo Bravo. That's easier for someone to understand my letters rather than just saying KB90KB. There are two organizations that provide emergency communications, the Radio Amateur Civil Emergency Service, or RACES, and the Amateur Radio Emergency Service, or ARES. The thing that both RACES and ARES have in common is that both organizations may provide communications during emergencies. The Amateur Radio Emergency Service is a group of licensed amateurs who have voluntarily registered their qualifications and equipment for communications duty in the public service. RACES is a radio service using amateur frequencies for emergency management or civil defense communications, or a radio service using amateur stations for emergency management or civil defense communications. It's also an emergency service using amateur operators certified by a civil defense organization as being enrolled in that organization. When an emergency occurs, it's common for amateur radio operators to form a network or net to facilitate emergency communications. The net is led by the net control station, whose job it is to make sure that messages are passed in an efficient and timely manner. Stations other than the net control station are said to check into the net. An accepted practice for an amateur operator who has checked into an emergency traffic net is to remain on frequency without transmitting until asked to do so by the net control station. Accepted practice to get the immediate attention of a net control station when reporting an emergency is to begin your transmission by saying priority or emergency followed by your call sign. Message traffic may be formal or informal. A characteristic of good emergency traffic handling is passing messages exactly as received. To ensure that voice message traffic containing proper names and unusual words are copied correctly by the receiving station, such words and terms should be spelled out using a standard phonetic alphabet. Formal traffic messages consist of 4 parts: a preamble, an address, a text, and signature. The preamble in a formal traffic message is the information needed to track the message as it passes through the amateur radio traffic handling system. Part of the preamble is the check. The check is a count of the number of words or word equivalents in the text portion of the message. The address is the name and address of the intended recipient, and the text is the message itself, while the signature is the part of the message that identifies the originator of the message. FCC rules always apply to the operation of an amateur station. Amateur station control operators are permitted to operate outside of the frequency privileges of their licensed class only if necessary in situations involving the immediate safety of human life or protection of property. One way to recharge a 12-volt lead-acid station battery, if the commercial power is out, is to connect the battery in parallel with a vehicle's battery and run the engine. An amateur whose license privileges allow them to transmit on the satellite uplink frequency may be the control operator of a station communicating through an amateur satellite or space station. As with other transmissions, the minimum amount of power needed to complete the contact should be used on the uplink frequency regardless of an amateur satellite or space station. Often the uplink frequency and downlink frequency are in different amateur bands. For example, when a satellite is operating in the mode UV, the satellite uplink is in the 70 centimeter UHF band and the downlink is in the 2 meter VHF band. Any amateur holding a technician or higher license class may make contact with an amateur station on the International Space Station using 2 meter and 70 centimeter band amateur radio frequencies. When used to describe an amateur satellite, the initials LEO mean that the satellite is in low Earth orbit. A satellite beacon is a transmission from a space station that contains information about a satellite. FM packet is a commonly used method of sending signals to and from a digital satellite. A satellite tracking program can be used to determine the time period during which an amateur satellite or space station can be accessed. The Keplerian elements are inputs to a satellite tracking program to track a satellite. Two problems that you must deal with when communicating via satellites is Doppler shift and spin fading. Doppler shift is an observed change in signal frequency caused by the relative motion between the satellite and the Earth station. Rotation of the satellite and its antennas causes spin fading on satellite signals. Contesting is a popular operating activity that involves contacting as many stations as possible during a specified period of time. When contacting another station in a radio contest, a good procedure is to send only the minimum information needed for proper identification and the contest exchange. In VHF or UHF contests, stations often send each other their grid locators. A grid locator is a letter number designator assigned to a geographic location. One fun activity that is very practical is radio direction finding. You would use radio direction finding equipment and skills to participate in a hidden transmitter hunt, sometimes called a fox hunt. In addition to participating in this kind of contest, radio direction finding is one of the methods used to locate sources of noise, interference, or jamming. A directional antenna would be useful for a hidden transmitter hunt. The maximum power allowed when transmitting telecommand signals to a radio-controlled model is 1 watt. In place of an on-air station identification, when sending signals to a radio control model using amateur frequencies, a label indicating the licensee's name, call sign, and address must be affixed to the transmitter. The Internet Radio Linking Project, or IRLP, is a technique to connect amateur radio systems, such as repeaters, via the Internet using Voice over IP, or Voice over Internet Protocol. As used in amateur radio, it's a method of delivering voice communications over the Internet using digital techniques. Stations that connect to Echolink or IRLP are called nodes. One way to obtain a list of active nodes that use Voice over IP is from a repeater directory. You access an IRLP node by using DTMF signals on your keypad of your radio. To select a specific IRLP node when using a portable transceiver, use the keypad to transmit the IRLP node ID. A gateway is the name given to an amateur radio station that is used to connect other amateur stations to the Internet. FCC rules. The amateur radio service is a service administered by the Federal Communications Commission. The FCC is the agency that regulates and enforces the rules for the amateur radio service in the United States. Part 97 is the part of the FCC regulations that contains the rules governing the amateur radio service. Part 97.1 lists 5 purposes for the existence of amateur radio: recognition and enhancement of the value of the amateur service to the public as a voluntary, non-commercial communication service, particularly with respect to providing emergency communications; continuation and extension of the amateur's proven ability to contribute to the advancement of the radio art; encouragement and improvement of the amateur service through rules which provide for advancing skills in both the communication and technical phases of the art; expansion of the existing reservoir within the amateur radio service of trained operators, technicians, and electronics experts; continuation and extension of the amateur's unique ability to enhance international goodwill. Also, allowing a person to conduct radio experiments and to communicate with other licensed hams around the world is an important aspect of amateur radio. The FCC Part 97 definition of an amateur station is a station in the amateur radio service consisting of the apparatus necessary for carrying on radio communications. The FCC definition of harmful interference is that which seriously degrades, obstructs, or repeatedly interrupts a radio communication service operating in accordance with the radio regulations. At no time is willful interference to other amateur radio stations permitted. The radio navigation service is one of the services that are protected from interference by amateur signals under all circumstances. If you are operating on the 23 centimeter band and learn that you are interfering with a radio location station outside the United States, you must stop operating or take steps to eliminate the harmful interference. The FCC Part 97 definition of telemetry is a one-way transmission of measurements at a distance from the measuring instrument. The FCC Part 97 definition of telecommand is a one-way transmission to initiate, modify, or terminate functions of a device at a distance. The frequency coordinator is the entity that recommends transmit and receive channels and other parameters for auxiliary and repeater stations. Amateur operators in a local or regional area whose stations are eligible to be auxiliary or repeater stations select a frequency coordinator. The ITU is a United Nations agency for information and communication technology issues. There are 3 ITU regions. North American amateur stations are located in the ITU Region 2. The frequency assignments for some U.S. territories are different from those in the 50 U.S. states because some U.S. territories are located in ITU regions other than Region 2. Amateur frequency assignments can vary among the 3 ITU regions. The questions that you might see on the test related to frequencies will be the following. 52.525 MHz is a frequency within the 6 meter band. The 2 meter band is the amateur band you are using when your station is transmitting on 146.52 MHz. 443.350 MHz is a 70 centimeter frequency authorized to a technician class license holder operating in ITU Region 2. 1296 MHz is a 23 centimeter frequency authorized to a technician class licensee. 1.25 meter band is the amateur band you are using if you are transmitting on 223.5 MHz. You should not set your transmit frequency to be exactly at the edge of an amateur band or subband for the following reasons: to allow for calibration error in the transmitter frequency display, so that modulation sidebands do not extend beyond the band edge, and to allow for transmitter frequency drift. CW only is the emission mode permitted in the mode-restricted subbands at 50 to 50.1 MHz and 144 to 144.1 MHz. The 6 meter, 2 meter, and 1.25 meter bands are the bands available to technician class operators that have mode-restricted subbands. The use of SSB phone in amateur bands above 50 MHz is permitted at least some portion of all the amateur bands above 50 MHz. Data is the type of emission that may be used between 219 and 220 MHz. One result of the fact that the amateur service is secondary in some portions of the 70 centimeter band is that the U.S. amateurs may find non-amateur stations in the bands and must avoid interfering with them. You may operate a transmitter on an amateur service frequency after you pass the examination required for your first amateur radio license as soon as your name and your call sign appear in the FCC's ULS database. 10 years is the normal term for an FCC-issued primary station/operator amateur radio license grant. When the FCC issues an operator/station license, the call sign of that station consists of 1 or 2 letters followed by a number and then 1, 2, or 3 letters. W3ABC is an example of a valid U.S. amateur radio call station sign. After you pass the test, the FCC will assign you a call sign sequentially from the pool of available call signs. If you do not like this call sign, you can apply for a vanity call sign. Any licensed amateur may select a desired call sign under the vanity call sign rules. Extra class licensees are the only ones who may hold a 1x2 or 2x1 call sign. K1XXX is therefore a vanity call sign which a technician class amateur operator might select if available. 2 years is the grace period following the expiration of an amateur license, within which the license may be renewed. If your license has expired and is still within the allowable grace period, transmitting is not allowed until the ULS database shows that the license has been renewed. Amateurs that set up stations at special events, such as a community fair or fundraising event, can request a special call sign specifically for that event. A special event call sign is the type of call sign that has a single letter in both the prefix and the suffix. At least 4 persons are required to be members of a club for a club station license to be issued by the FCC. Only the person named as the trustee on the club station license grant may select a vanity call sign for the club station. Should you move, you must inform the FCC of your new mailing address. Revocation of the station license or suspension of the operator license may result when correspondence from the FCC is returned as undeliverable because the grantee failed to provide the correct mailing address. You are allowed to operate your amateur station in a foreign country when the foreign country authorizes it. An FCC-licensed amateur station may also transmit from any vessel or craft located in international waters and documented or registered in the United States, in addition to places where the FCC regulates communications, but you need permission from the captain first. Any language that is considered obscene or indecent is prohibited. The only time an amateur station is authorized to transmit music is when incidental to an authorized retransmission of a manned spacecraft communication. The transmission of codes or ciphers that hide the meaning of a message transmitted by an amateur station is allowed only when transmitting control commands to space stations or radio control craft. An FCC-licensed amateur station may exchange messages with the U.S. military station during an Armed Forces Day communications test. FCC-licensed amateur stations are prohibited from exchanging communications with any country whose administration has notified the ITU that it objects to such communications. However, there are none at this time. Amateur radio operators may not use their stations to make money, except in some very special circumstances. For example, the control operator of an amateur station may receive compensation for operating the station only when the communication is incidental to classroom instruction at an educational institution. Amateur radio operators may use their stations to notify other amateurs of the availability of equipment for sale or for trade, but only when the equipment is normally used in an amateur station and such activity is not conducted on a regular basis. All amateur communications must be station to station. That is to say, amateur radio operators may not broadcast. The term broadcasting in the FCC rules for the amateur services means transmissions intended for reception by the general public. Only when transmitting code practice, information bulletins, or transmissions necessary to provide emergency communications may an amateur radio station engage in broadcasting. Amateur stations are authorized to transmit signals related to broadcasting, program production, or news gathering, assuming no other means is available, only where such communications directly relate to the immediate safety of human life or protection of property. Communications incidental to the purposes of the amateur service and remarks of a personal character are the types of international communications that are permitted to an FCC licensed amateur station. Only a person for whom an amateur operator or primary station license grant appears in the FCC database or who is authorized for alien reciprocal operation is eligible to be the control operator of an amateur station. The FCC presumes the station licensee to be the control operator of an amateur station, unless documentation to the contrary is in station records. An amateur station is never permitted to transmit without a control operator. The station licensee must designate the station control operator. When the control operator is not the station licensee, the control operator and the station licensee are equally responsible for the proper operation of the station. The control operator of the originating station is accountable should a repeater inadvertently retransmit communications that violate FCC rules. The class of operator license held by the control operator determines the transmitting privileges of an amateur station. At no time, under normal circumstances, may a technician class licensee be the control operator of a station operating in an exclusive extra class operator segment of the amateur bands. Two related concepts are the control type and the control point. An amateur station control point is the location at which the control operator function is performed. Local control is the type of control being used when transmitting using a handheld radio. Operating the station over the internet is an example of remote control as defined in Part 97. Repeater operation is an example of automatic control. APRS network digipeaters operate under automatic control. A station is required to transmit its assigned call sign at least every 10 minutes during it and at the end of a communication. The only time an amateur station may transmit without identifying is when transmitting signals to control a model craft. The English language is the only acceptable language for use for station identification when operating in a phone subband. Sending the call sign using CW or phone emission is the required method of call sign identification for a station transmitting phone signals. For some types of operations, using a tactical call, which describes the function of the station, is allowed. For example, a tactical call is the type of identification being used when identifying a station on air as the race headquarters. When using tactical identifiers such as race headquarters during a community service net operation, your station must transmit the station's FCC assigned call sign at the end of each communication and every 10 minutes during a communication. When operating mobile or portable, or when you wish to note something about your station, you may use a self-assigned call sign indicator such as /3, mobile, or QRP. All of these are valid examples. KL7CC stroke W3, KL7CC slant W3, or KL7CC / W3. Indicators required by the FCC to be transmitted after a station call sign include /KT, /AE, or /AG when using a new license privileges earned by CSCE while waiting for an upgrade to a previously issued license to appear in the FCC license database. Third-party communications are communications on behalf of someone who is not the station licensee. For example, if you have a friend over to your house and let him or her talk on your radio, that's a third-party communication. These are entirely legal within the United States, but there are some restrictions when you are in contact with an amateur station in a foreign country. The FCC rules authorize the transmission of non-emergency third-party communications to any station whose government permits such communications. A non-licensed person is allowed to speak to a foreign station using a station under the control of a technician class control operator, only if the foreign station is one with which the U.S. has a third-party agreement. The station licensee must make the station and its records available for FCC inspection any time upon request by an FCC representative. And that's it. Other resources. There's a lot more information out there on these topics, and this is meant as an introduction and to present you with the information that you need to know to pass the technician test. I hope you found it helpful. To review in book form, I highly recommend the No Nonsense Technician Class Amateur Radio License Study Guide by Dan Romanchik, KB6NU, which this presentation is based on. He also has guides for the general and extra classes available at a nominal cost, and I highly recommend those. They both helped me pass my general and extra tests. I also strongly recommend studying the flashcards and practice tests at hamstudy.org. The flashcards at hamstudy.org are invaluable to learn the material that I presented. I highly recommend that because it's a smart flashcard system that will learn which questions that you get right and you get wrong, and the ones that you get wrong, it will keep presenting to you until you start answering them correctly. So you learn as you take the flashcards and you remember the correct answer. And then when you get your aptitude up to a suitable level, you can take the practice tests and make sure that you're ready. Take a few practice tests, make sure you're consistently passing, and make sure you're ready, and then go take the test. I wish you the very best of luck, and if you need to get a hold of me, you're welcome to email me at david@bottomley.us. That's david@bottomley.us. Thank you very much.